we are taking up hydrolysis of salt. For hydrolysis, one has to understand what is neutralization reaction, and everybody understands that acid and base react together to form salt. That is what we call neutralization reaction. If for acid and base both be strong, then what happens? Equilibrium constant value comes very high. It is 10 raised to the power 14 at 298 Kelvin temperature, simply speaking 25 degrees Celsius. So for all practical purposes, the process is irreversible. On the other hand, though equilibrium constant value for weak acid and weak base is also very high, but several order lower than the equilibrium constant for a strong acid and a strong base. Therefore, we consider neutralization reaction between weak acid and weak base as reversible. Now, what is hydrolysis? Hydrolysis is just opposite reaction to that of neutralization. That is, the reverse process of neutralization reaction is hydrolysis. We are considering, just to understand, let's consider weak acid and a strong base to give salt. Okay, so let HA be weak acid and a strong base, let it be B. This will be BH plus, because B is base, it can accept proton from weak acid HA, that is BH plus and A minus together, or simply this is BHA. No confusion. This BHA gives BH plus ion and A minus ion. BH plus ion and A minus ion. Now from weak acid we get A minus. So this A minus is hydrolyzed. So A minus plus H2O, this will give HA plus OH minus. This is hydrolysis reaction. This is principal reaction. Principal hydrolysis reaction. Okay. And the equilibrium constant corresponding to this equilibrium is known as hydrolytic equilibrium constant or hydrolysis constant, hydrolytic constant, or this hydrolytic equilibrium, and this is denoted by KH. Hydrolysis constant. So this is HA, concentration of HA into concentration of OH minus by concentration of A minus. Okay. Also, suppose initial concentration of A minus is C, so initial concentration of HA and OH minus will be 0, and at equilibrium what will be this? C minus C alpha. Alpha is degree of hydrolysis, so we have C alpha and C alpha. Okay, so for this OH minus we have C alpha. Accordingly, KH will also be equal to C alpha into C alpha by C1 minus alpha. Concentration is not 0, therefore we can cancel, and this will be C alpha squared by 1 minus alpha. Since alpha is very less than 1, therefore KH will be equal to C alpha squared. KH will be C alpha square. Okay. So here we are noting important thing. KH is equal to C alpha square. That means alpha is equal to KH by C. Alpha is equal to KH by C under root. Okay. Now that we can also consider another equilibrium, that is HA plus H2O. This gives H3O plus A minus. And this is acid, therefore Ka, that is equilibrium constant for weak acid, will be equal to H3O plus, concentration of H3O plus into concentration of A minus by concentration of HA. Now check here, KH can be written, this is concentration of HA to concentration of OH minus by concentration of A minus. Suppose we are multiplying it by H plus concentration on the numerator as well as denominator side. So certainly this factor is Kw. This factor is Kw. And HA by A minus H plus, here also HA, H plus, A minus, but they bear reciprocal relationship. Therefore, KH is equal to KW by KA. So another important thing, what we are considering here, that KH is equal to KW by KA. KH is equal to KW by KA. This is KH. Certainly this relationship shows that the value of hydrolysis constant will be larger if the value of acid ionization constant is lower. They bear reciprocal relationship. Ka decreases, Kh increases, Ka increases, Kh decreases. Okay, so these are important relations. Here, what we can write, now check here, for this OH minus ion at equilibrium, we have its concentration at equilibrium. At equilibrium, this concentration is C alpha. Therefore, OH minus concentration will be equal to C alpha, that is C. And what is alpha? Here we have KH by C under root. And now this is root C, and root C will be cancelled, root C will be left, that is KH into C. Okay, and now this under square root KH into C, now this KH is equal to KW by KA, therefore we can write here KW by KA for this KH, and this is C. Okay, so this is the expression for OH minus. Now we are removing all these things for want of space. Now check here, OH minus ion, OH minus ion. Now see, OH minus ion concentration is equal to KW by KA, KW into C, the square root therefore power half. This is OH minus ion concentration. As a result, minus log OH minus concentration will be equal to minus log KW by C, KW into C by KA raised to the power half. Okay, minus log, same thing. Both sides negative logarithm we have taken. Now this is minus log OH minus ion is POH. And this will be, okay, take minus constant, minus is common, okay, because log m raised to the power n is equal to n log m, therefore this half factor we are bringing it here, n, and this is what is log kW plus log C minus log Ka. This is the expression for POH. Clear? Very simple. Now that at 298 Kelvin we know pH plus POH is equal to 14, or pH will be equal to 14 minus POH. This is 14. For 14 we can write pKW. At 298 Kelvin, pKW is equal to 14. So pKW minus POH. Okay, that is pKW minus, and now we are writing for POH. Here what is POH? Minus half log KW plus log C minus log Ka. Okay, this is your pH. See, minus log Kw is pKw. This minus log Kw is pKw. So pKw into half pKw. So pKw minus half pKw, that is half pKw. Okay. Now check. Here we have minus half log C, and here is minus sign, so minus into minus plus half log C. Clear? Now check. Now here we have minus log Ka. This is pKa. This is pKa into minus sign minus pKa into this minus sign plus pKa and this half factor plus half pKa. Everywhere we have half factor, therefore this is simply half pKw plus pKa plus log C plus log C. Check. Half pKw plus pKa plus log C. Is it? Okay, now here minus POH. So POH is minus half. We are writing minus half. Okay, I was interpreting. This is not. This is minus half. Minus half, and rest is okay. Log Kw, log C minus log K. Okay. Now that this will be equal to half pKw, as we have explained. pKw, because minus log Kw is pKw, that is minus half pKw, and into this minus sign plus half pKw. Is it clear? This is minus half log C, and into this sign plus half log C, and this is pK minus log Ka is pK. So minus pK into minus plus pK, this half factor, so half pK. Finally pH is equal to half into pKw plus pK plus log C. Is it clear? In this connection, if you have understood, the very important point I am trying to tell you, that you can remember this expression very easily. What I wish to say, see, there are three cases. Check. This is a strong acid, weak base. This is weak acid, a strong base. This is weak acid, weak base. Okay. So we are trying, suppose this also gives salt, this gives salt, this gives salt. As I have told you earlier, either of them must be weak. Here this acid is weak, here base is weak, here both are weak. Okay, we can understand the pattern, and we can write pH expression for all of them. If we understand that when acid is weak acid will have plus pK, also plus log C. Clear? And for weak base will have minus pKb. Mind it, for base this is Kb, base ionization constant, and minus log C. And for weak acid and weak base will have both half plus pKa minus pKb, and both plus log C and minus log C both add up, that is nothing, 0. Therefore for this case, that is weak acid and strong base, the expression for pH will be equal to half, this is common, half pKw in all these three cases. Same. Okay, this is weak acid, what we have to write? Plus pK, write pK, this is plus log C. Clear? pKa. For this case, when weak base and strong acid, pH will be equal to half, this will be pKw, and for this minus pKb minus log C. Clear? For this case, when both are weak acid and weak base, right, pH will be equal to half, again pKw, same thing, and pKa will be positive, plus pKa minus pKb, and plus log C and minus log C cancel it. So if somebody asks you what will be the pH for hydrolysis of salt generated by weak acid and weak base, you can say pH is equal to half into pKw plus pKa minus pKb. For hydrolysis of salts or for salt solution, when we have weak base and a strong acid, pH is equal to half into pKw minus pKb minus log C. In case we have weak acid and a strong base, then pH of the salt solution will be equal to half into pKw plus pKa plus log C. So you need not remember all the three expressions can be derived, and this is a beautiful pattern we can remember. This will serve you as mnemonics. Thank you.